Just wow. So the DApp side, the ICP side will be really quite something. Um, okay, how's that happening then? Uh, so whether a name service or not, I mean that's just icing on the cake. That just makes things easier for users. But I mean, we don't want everything running on the web server. The web server is kind of a liaison layer to the presentation layer. But behind the scenes, things are not done like they used to be. Server architectures. That is to say, with microservice agent based technology, that web server would be implemented with agents, many agents. Get used to it, many to many. Um, so how do they do the processing? Well, from the human side of it, really, all a web server is regurgitated files. So now we're taken to IPFS. But a web server in its most axiomatic form would be a URL is sent to the web server. The web server takes that and says, "Oh, you mean this HTML file here?" It just, in its rawest form, it just picks it up and sends it to the client, which is the browser. We call them the browsers. And it's the browser's job to render that based on HTML. We're in its most primitive again. We're not talking scripting languages like JavaScript or anything yet. See, part of the problem with web technology was that inherently it was supposed to be open source. It was supposed to be wide open. I mean, HTML has that same problem that JavaScript has. Anybody can pop the hood and look in there and probably even modify it and spoof being the original web server and stuff. So cyber, very, very weak cybersecurity wise. But how the nature of these things is they come into public consumption and each outfit is looking for a competitive advantage, some kind of leverage, if they can get away with the proprietary platform, and that's what we want to get eventually, is Lily's being rather slurpy. Um, yeah, good work if you can get it. So that's the crudest web server. I really, somebody should drill down and find out. Somebody must already be doing this. So we should be able to pick something up and plug it in. But, and I was talking about killer apps and stuff, and that's what's happening right now is there's a lot of bounties being offered and grants and such to implement applications on these systems. Because if they don't get to a critical mass of that or have a killer app like for Ethereum, it was CryptoKitties. Look up CryptoKitties sometime. I bought some CryptoKitties, but I do think they had, that is to say, years later, you can't use them anymore, so it doesn't matter much. Um, but yeah, the CryptoKitties, I'm sure, has been done over and over, and certainly can be done. Um, Okay, so use cases. We're to the point where we've got a web server and stuff, and I'm not gonna. I mean, yeah. Then next, you've got to support a programming language like Python or JavaScript or PHP or whatever. Um, and that, of course, gets a lot more elaborate. But, and it's a big but, eventually we're going to want our system to be able to at least write. One thing you can do is get your system to learn how to output a script that then you can call a command shell and say, read that script and process it, send it to a scripting engine. And that's incredibly powerful. And one way you can make a machine maybe being somewhat self-configuring, or at least somewhat uh, self-configuring based on weighted experience. So what I was pursuing is, let's leave the web, let's say our web server, especially because we go for microservices. Maybe it's a microservice. Maybe our web server is actually an NFT. It's a microservice. Oh, that brings up a whole area. I mean, I was talking about linkage between these microservices, agents, if you will. How is it done? Because you don't you could use T TCP/IP as a model, but you don't have to implement it that way, and it probably would be best not to implement it that way. So you get a society of mind, so to speak, agents that get linked up through whatever mechanism, we don't know at this point, maybe friends, associates, nearby nodes. Uh, you have kind of a ripple effect of knowledge that would go through the agents. Because basically what I'm thinking of is, well, agents that know agents are the luckiest agents in the world. Um, let's say, I mean, the identifier is the crypto address, maybe many, but that's what they deal in. That's their currency. Wow. Maybe it's hard to get the humans out of the picture altogether. Maybe we configure hard code some agents that go out into the cloud. What if we create a creature, an agent that runs in the cloud, however it can survive, however it wants to do it? But how does it get linkage with other agents? But we could send an agent that's its job. It's kind of like a lookup table or a glossary, or dictionary, whatever, a list of addresses. So we'd have to at least provide a docking port or something for a brand new agent to come in and say, "Hey, I'm an agent. I want to be part of the system, and here's my ID, here's my brand or whatever." And that app, which by its nature could not be a D app, I don't think, would be very difficult. So, hard coded in some fashion at least. But it goes out into the cloud and broadcasts, kind of like DHCP. Because again, we're talking about a new agent coming in. It doesn't know this list. It knows nothing except for what we hard code into it. And we want to avoid that as much as possible. Because if it's explicit and hard coded, then that's a failure point and security point. So, so the new agent needs to listen for this librarian or list agent. It needs to be a broadcast on something that is shared in common. Yeah, that's what we need. And I don't think that'll be a huge problem because that's basically what blockchain is. It's a ledger. And anybody supposedly can read that ledger if they have the address. And we can when we get into tokenization, we can always spin up a new token and use it for a purpose. I'm trying to avoid explicit data uh, that may or may not be there in the future. So you need with TCP/IP, it's 255. Any TCP/IP service or what have not should be listening on 255 for broadcast messages meant for everybody, and then you decide. So I don't know. I'm going to think about that for a bit because zero knowledge, zero knowledge finite machine. We want to consider that as much as we can. This guy can put a record on the ledger saying, "Hey, I'm such and such, and anybody that does such and such." Maybe we should make a hard-coded address that it's only used for that purpose. To say, hey, I'm looking for start a protocol, a handshake. Hey, I'm looking for a librarian. And the librarian comes in. Now it knows this one's address and can speak more directly and say, "Hello, I'm a librarian and I've got this address. Please remember that." And then we've got it. Once we've got that, we've got it. Yay for